Hi, welcome to OLI Systems training videos. Today we're going to have an introduction to the OLI Flowsheet simulator. Before you is the simulator, and like any good simulator, there are various panels that you can move around and dock. We're not going to do any of that for this initial tutorial. We have the navigator panel here, which is where we're going to define our chemistry and some of our unit operations. Here is our library of unit operations. Various properties will be displayed depending on where we are in the flow sheet. And this is our trace window where we will get output as required. So the first thing we're going to do here is go through a very basic introduction. The palette out here is the process flow diagram, nothing on it, of course. We can talk about chemistry here, and we can generate reports. Of course, there's nothing here to report. So we are going to first start with chemistry. Now, for this example, we're going to be using our more traditional aqueous thermodynamic model, sometimes known as the hydrogen ion model. Okay. And we always start on this page. We can add databases to this. We have some databases here already loaded. Some are from OLI, some are user created. Then we can go into our inflows. In this particular example, we are just going to add a very simple set of chemistries. We are just going to type in the box our first component, which is ammonia, and I'm using the chemical formula here. Then carbon dioxide. You see I'm typing in lowercase sulfur dioxide, and it automatically converts to upper. Hydrochloric acid. Now, I'm stopping on hydrochloric acid here to let you know that there are a bunch of different species that have HCl in their name. So we're searching here by name and not by formula. So I have hypochloric acid here, the various other higher oxidation states. This guy is heptachlorodibenzofuran. And you can see that HCl appears in the name. We don't want any of them. We're just taking the straight hydrochloric acid. Sulfuric acid is there, and you can see there's many selections, and sodium hydroxide is the last species. We were already on databanks. We're not changing anything there here. We're going to go to phases. We allow all the possible solid phases from those chemistries to be created. You don't have to type in any of these. This is all of the solids related to sodium, carbonate, sulfate, and so forth, as well as ammonia in the list. We can also turn off individual ones. If you know you didn't want certain sulfate species, you can turn them off by unclicking. But we're not going to do that. We're going to leave them all here. We do allow redox. This example is not about redox. We do allow reaction kinetics. Ditto, not about reaction kinetics here as well. So we're going to go back to the flow sheet. We're going to start off with just putting a simple mixer. I click and I can drag out here. Up here is our connector for streams. So we'll just start adding streams. There's a recommended connector. And I want to get off adding streams now. So I can click on the stream S1. I can rename it. S1 will be called base waste eventually. I can double click it and type in base waste. And like any good flowsheet simulator, I can move the name around. The other stream will be known as acid waste. I'm going to do this a little bit differently than how it was named. Over here on the definition, actually I have to name it here. We'll go ahead and name this acid waste. The mixer is just going to be called Mix 1, and the output stream is going to be called Mixed Waste. Or you could have left the names that we recommended. So we're going to start off with adding our first stream here, which will be the base waste. I click on it. And over here in the tab, you can see the properties. The temperature, in this case, it's 40 degrees centigrade. In a different video, we will show you how to change units. It is going to be at 1 atmosphere, and we're going to have 200 moles. of it. We're going to start off at 55.5082 2 moles of water. That is a kilogram of water. And then we're going to have 1 mole of ammonia and 0.1 moles of both carbon dioxide and SO2. We're going to go over to acid waste, and we're going to add it. Okay, this one will be at 25 degrees, 1 atmosphere, but total moles of 150 moles. Once again, same value for water. In this case, though, hydrochloric acid will be 0.1 moles, and the sulfuric acid will be 1 moles. And you can see that we're totaling up the total moles here. We will eventually take this 56 and escalate it or multiply it up to 150. The mix block is a standard mix block. It is currently set to adiabatic conditions, no heat loss, and we're going to take the smallest inlet pressure. The duty is defined to be 0, although we could have an offset here. And we're now ready to go run it. And we'll go ahead and do that. The little run icon is up here, or you could press F9. You can see it runs quickly. The trace window is telling us where we are in the process. The scroll bar is just to give you an idea that we're actually doing something. Simulation is complete. So we can do some things here. We can actually go and look at the base waste and click Calculated, and we get some information. The pH of this stream happens to be 9, approximately. Here is the acid waste. Its pH is essentially 0. That's a very small number. And the mixed waste has a pH of 1.1. Those are very handy things to look at. We could also click on the stream, right-click it, and add a call-out. Okay. And we have the summary of that. We'll do that for all 3 of our streams. Okay, so you see that there was actually either a cooling or a heating, depending on your viewpoint here. Okay. But now we can go on. We're actually going to take this stream. This stream here in mixed waste actually has some additional information. If we go back to our panel, you can see that on a mole fraction basis, it's about 99.9% liquid and a little percent of vapor. We can now look at all of the stream compositions here. We build a report here, and we're just going to add all streams. So there's only 3 streams here, so you can see a summary of all the stream data as well. If we go on down here to phase flows, we tell you that there's a little bit of vapor in this final stream. We can scroll on down to see more. We give you much more thermodynamic data. The actual true species in solution. Okay, we also give you the vapor. There were no solids here, so there's no solid data. We're going to go back to the flow sheet, and we're going to add 2 more blocks. The first block we're going to add is a phase separator, just called the separator. And I tend to build the model as I go. I'm just going to grab, let's move our label out of the way. I can grab the little handle right there and just connect it right to the separator. The separator needs a minimum of a liquid out, but you can also have a vapor and a solid. So all we're doing here is sending the vapor out one way and another. You notice that this little warning has popped up that says the simulation has changed. The results may be out of date. That's true. I added a block. I'm just going to go ahead and dismiss that. I can rename the vapor. This will be liquid. Not very imaginative here. And I know I have no solids, but I'm just going to write the word solids here. Okay. The last block is a pH neutralizer. Down here in the grid, we can find our pH neutralizer. There he is. The icon looks very similar to the separator, once again, I grab the handles, connect it. I will have an outlet. This one will require a new inlet. Okay. To quickly get off of stream inlet mode, press the escape key, and that allows you to quickly edit the streams. I'm going to add this. This is going to be the caustic, otherwise known as sodium hydroxide stream. And this is just a neutralized liquid. We'll just move things around a little bit. The caustic stream, 25 degrees, it's going to have a value of 100. Once again, we're using that 55.508, 2, and 1 mole of caustic. This block, if I run it, will give me an error because this block requires us to set a pH. And if you remember, this mixed waste went from 1.1 of a pH, and we're going to bring that up to 9. Okay. At this point, it's probably a good time to save the process. I'm an old school simulator engineer, so I know that I entered all this data and I may lose it. So I'm going to go ahead and save it. You notice the file name is defaulted to ESP1 with a little asterisk now. That means I've changed it. So we are going to go ahead and save it. OLI allows you to save it in the program files. This is a very bad idea. We should not save it here. And rather, I'm going to save it in my documents folder. We create a folder called My OLI Cases, and then we have lots of different places, Flowsheet 11. I'm just going to put this in this one I call it Neutral 1, and save it. I'll now rerun it. It runs very quickly. And let's take a look at some more callouts. I will add a call out for the caustic. But what's important to know here is not so much the pH of the caustic, we know it's pretty high, is the flow. And we're going to go ahead and edit this. Edit, and we're going to go into phase flows, and we want total moles. So if you remember, I entered in 100 here. There's the 100. And now it's at 277. So I needed 277 moles of this to get to my spec value of pH of 9. I'm going to confirm that by, once again, adding a call out. And you can see that the pH is 9. We can add more information to here. We can go back to the report. Okay. We'll again add all the streams. Now they're all added here. We've already looked at the base waste and acid waste, mixed waste. The liquid, vapor, and solids, not as much interesting. The last stream is the neutralized liquid, and where we give you some data here. Here's the full amount of species in solution. Again, no solids. Here's the full detailed list. Here's an apparent list. Sometimes it's easier to look at how much caustic was actually here or consumed. You can look at it there as well. More details to look at here. You can copy and paste all of this, and it can be brought into Excel. You would just go into Edit and Copy, and this can be pasted into another program. All right, and once again, always good to save your file, which I've done. And now we can go on. And there will be a separate video, probably in a week or so, to show you some more getting started functions of OLI Flowsheet. Thank you.